All right, what are we talking about, Day?
Tools.
What about the tools?
What they do and what they are.
Well, we're talking specifically about these sockets, right?
Yep.
So we got sockets, and we got sockets. Get the metric ones out. So what did we say the difference was between these?
One's metric, one's 12
these are both.
point, and one's 6
All
point.
right, so one is 6 point, and one is 12 point. Why does that matter?
Because on 12 point, you need to get more speed. But you might strip out a rusty bolt with them, so that's why they made 6 point.
Well, that's right. 6 point fits the bolt tighter, so you won't strip it out. But these are easier to get on because you have more than one shot at it, right?
Yeah.
So these are better. That's why we have 6 point and 12 point sockets. But we're going to talk about how you measure them. So these are both metric. We'll do those in a minute. These are standard. So if you read these, they have fractions on them. That one say
5/8.
5/8. So they all have those on there, and we're going to talk about what that means, how they got those fractions. That's uncomplicated, isn't it?
Yeah.
Easy peasy.
Yeah, I almost did that 5/8 in my head. But I'm like, that's a lot of 8s. It's got to equal like maybe, let me think. 8 plus 8, 16, right?
Uh-huh.
16 plus 16.
Are you on a tangent? We going somewhere?
16 plus 16, that would equal...
Close.
42.
32.
32. Ah.
That's not what that you're just going off on some weird tangent. What this is these are a division of 1 inch. So all of these, put the ruler down here, are smaller than from here to here. And we got bigger ones in the barn. Remember we had those 1.75" out?
Yeah.
Yeah, those are big. But everything is an inch. So all they've done is they've taken an inch. We're going to make this an inch. This would be 0 inches. And this would be 1 inch. Right? Mm-hmm. Oh, I think I'm off camera. I'm going to have to, let's move it down. 1 inch. 0 inches. All right. So all they've done is they've divided this up. So if we drew a line from here to here, and we put a line right in the middle, what do you think that would be?
1/2 inch.
It'd be 1/2 inch, right? Because we have halves on each side, right? That's not a very good looking 2.
Don't worry, I draw my 2s even worse.
My handwriting's going to kill us here, isn't it? All right, so that's the easy one, right? But that's all they did. They started with 1 inch, and they've just divided it into pieces. So if we want to divide it again, here's where it starts to get fun. We're going to divide this in here. Now what do we get?
1/3 of an inch.
No.
1/3 of a quarter.
If we divided it equally, 1, 2, 3,
4.
so that'd be 1/4 of an inch, right?
Well, you know, these are pretty easy.
So, but look here, here's where it gets hard, ready? 1/4, half, which is 2/4. This is the same as 2/4, right?
Mm-hmm.
What would this one be?
1/3.
1/4, 2/4.
3/4.
This one would be 3/4. But we don't use 2/4 because we can reduce that. So we reduce that back to half. See how 2's, you could divide them both in half and you get 1/2. You notice that 2 plus 2 is?
4.
1 plus 1 is?
2.
So all we've done is we've reduced this. So we've reduced this down to the 1/2. So we divide it further. All right, well, how many are there?
4/4.
No. Well, I mean, technically, it could be 4/4. If we put that up here, it could be, well, it would be 4/4. In this case, it'd be, we're doing eighths now. See, we got 1, 2, 3, 4, 5, 6, 7, 8. 4/4 would be this. 4/4 be the same as 1 because they're even, right? The full amount. So we're dividing this.
4/8.
Well, it would not be 4/8. This would be, how many eighths do we have? 1, 2, 3, 4, 5, 6.
7. 7/8.
So that'd be 7/8. And let's move our paper down. We're getting off the camera a little bit. Okay, we can see better. All right, I've got all my scribbles. No one's gonna be able to make fun of my scribbles because we can't see them. We'll move it down, then we'll move it back up later, right? There we go. All right, so if that's 7/8, what is this one?
6/8.
Close, count them.
5/8.
That one would be 5/8. What's that one gonna be?
3/8.
What's that one?
1/8.
All right, that wasn't that hard, right?
Yeah.
Now, we're going to divide them again. Well, we can look at something real quick first of all. So we said that this was 2/4, right? That's half. So if we wanted to do these in fourths, or all of them in eighths, so we have 1/8, what would this one be up in eighths?
1/8.
No, that's 1/8. What would this one be?
2/8.
That'd be 2/8. But notice we can reduce it just like we did that one, right? So we reduce it, we just call it 1/4 because we can reduce that to 1/4. And that works the same way across. So that's 3/8. This one would be 4/8, right? This one would be 5/8. This one could be easily 6/8. And all we're doing is reversing them, right? And then this one again would be 8/8, the full amount, right? All we're doing is dividing it. All right, you ready to go further?
Yeah.
One more. We're going to divide each of these in half again. All right. Now, how many do we got?
We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16.
16ths. So we know that this is the first one. That's 1/16. This one could be 2/16, but we're going to reduce it to 1/8, right? What would this one be?
3/16.
This one would be
4/16.
4/16. We're going to keep reducing it though.
5/16. 6/16.
Wow, it's 6/16. Okay, I guess it would be 6. I'm ahead of myself. 6/16, which we're going to reduce. All right, what's this one?
7/16.
And this one would be
8/16.
8/16, which is half, right? Notice 8 plus 8 is what?
16.
All right, what do we got here? That's 8.
9/16.
9/16.
10/16.
Yeah, we're going to reduce that though, right? We're going to keep that reduced.
11/16.
11/16. And this is 12/16, right? But we're going to keep reducing that down to here. Right here.
13/16.
16ths. Oh, that's not a very good 16, is it? 16, my handwriting's going to kill us. This would be 14/16, right? But we're going to keep reducing it to 7/8.
15/16.
And then we get back to 16/16, right? All we're doing is we're dividing this up into a certain number of parts. And that's what these do, right?
It really only goes to 12 in inches.
Well, that's because they're inches. That's a foot. 12 inches makes a foot. Base 12, right? We'll talk about that. So all they've done is they've taken all of these sockets and they said, all right, well, that is not a whole inch. It's part of an inch. And this happens to be 5/8 of an inch. And then they said, okay, well, this one's also part of an inch. That happens to be 9/16 of an inch.
This might be a way to organize your sockets.
It sure is. That's
Write down a ruler.
So when I'm out in the shop and I said, hey, I need a 9/16 socket, you can kind of look at these and go, all right, I can read every one of them, right? But you can also use your melon. What's half a 16?
8.
8. So if these are half and half, right? Then which side is a 9/16 on? Is it bigger than half or smaller than half?
Probably bigger than half.
Because it's one more than 8, right? So 9/16 is one bigger than half. So when you're looking at this socket rack, you can be like, well, it's going to be bigger than 1/2 inch. So this is the 1/2 inch. That must be 9/16, right? Now here's the fun part. You can divide this again. Let's move them down. We're running out of room to write. All right. And if we divide them again, we're going to do the bottom ones this time. How many of those do we got?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 31.
32. You ran out of fingers, right? It's 32 of them. But it works the same way, right? So if I do this first one, how many do I have?
130.
30 seconds.
130 seconds.
And then this one would be 2 30 seconds. But remember, we're going to go ahead and simplify it to 1/16, right? And this one would be 3 30 seconds. We're going to add room to write because it's so small, right?
4 40 seconds.
And that's what happens on this ruler too. If you notice, they've marked the inches 1, 2 because those are easier to read, and they've told you that these bigger lines are 16ths. But look, they also have 1 32nd there. But there's no way you could put the numbers on there and still read them, right?
Yeah.
Because they'd be so small. So they're running the same problem. But all they're doing is dividing this up into a bunch of pieces. All right, so we can go all the way across this until we get to 32 30 seconds, the 1 inch, right?
Mm-hmm.
Now guess what?
What?
Could we divide it further?
Probably not.
Sure we could. We could divide it yet more. Let's do it down here though, right? Because there's no way, right? So let's do it on this side. If I divide these yet again, how many would I end up with? If I had 32 before, and I just doubled how many I had?
That would be 42.
64.
Ah!
64ths. So we can measure this in 64ths, and then this would be 63 64ths, and this end one would be 64 64ths. How small a line do you think a 64th is on here? Look how small these 30 seconds are. Look at those. Look how small those are. Could you think about getting a line between those for 64ths? It'd be hard to read, right? So you know what we do instead?
What?
We switch to decimal and start using the micrometer, because then we can move to thousandths, which is the exact same thing, right? So all they've done for thousandths, taken this exact same inch, only we're going to divide it 1,000 times. And then this would be 1 1,000, 2, 3. So that's all they've done. They divided this same thing into multiple parts. So that's all you're doing, right? That's how these work. Now here's the funny thing. Those are American Standard, or Standard. Well, they're just standard. These ones are metric. They don't work the same. When they did these, when we did this, we decided to divide an inch into halves, and then 3/4, and then 8ths and 16ths, right? Metric doesn't work that way. Metric, they decided to go a different way. So if we look at this metric side of this ruler, we'll flip it over, right? Look at this metric side of the ruler. This is the millimeter side, right? Mm-hmm. So they have all of these big numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are centimeters. Takes 10 millimeters to make a centimeter. So what they're going to do instead is they're going to divide these up, and instead of dividing a known amount, that's what we did here, right? We started with a foot. We took this ruler, or we took an inch, but still, same thing, right? And we divided it. They didn't do that. Metric decided, make sure I don't run out of paper. Metric decided, instead of doing this, which is kind of silly and hard, fractions are hard, right? Mm-hmm. Well, let's not do that. What they decided is, like, just start with a small measurement. And we'll call this a millimeter. And that's 1 millimeter. And let's just add a second one. And that's 2, and that's 3, and that's 4, and that's 5, and that's 6. We're getting a little spaced. They're even spaced. I just can't draw, right? 8, 9, 10. And they just kept going. So if you look at these, you pull one of these off of here, that's a 13 millimeter. That means whatever this base measurement is, it's 13 of them. And if we look at here, this base measurement here would be 10 of them. So they got 10, 12. Do I have 11? 12. I skipped a number. You didn't tell me. Look at that. I can't count either. I can't count. I skipped a whole number. That's why I can't do math. I can't count. 12, 10, 12, 13. There should be an 11 here. I feel like we should put an 11 here now, right? 11. 12, 10, 11, 12, 13. So if we did that, all they've done is divided theirs differently. But this is easier, right? Now, if I need you to bring me a 14 millimeter socket. You can do the same thing we did with that. You can look at the socket rack and go, wait, what's that one say?
16 millimeter.
That one says 16. So which way am I going to go to get 14? All right, now you can't read the 14 because it's turned the wrong way, but which one is it?
16, 15, 14.
Yeah, even though you can't read it, it's got to be that one, right? And sure enough, 14 millimeter, right? So that's how you tell what size sockets are. And that's pretty easy, right? So you can get me sockets now. Or you can use your own sockets, right?
Yeah.
You know which sizes. All right, so that all makes sense?
Yeah.
What about those?
Deep well.
Deep well, what do we have deep well sockets for? Oh, they're heavy.
Mostly spark plugs.
Well, spark plugs need a deep well socket, but why do they have to be deep well?
So you can get deep bolts.
That's right, because sometimes
Tall bolts.
you got stuff in the way, right? And you still got to get the nut, and there's a big thread on there. You got to be able to get down into it. So that's deep well. Remember, we had to use these on the tractor to get the injectors out, right?
Yeah.
Because you had to get the down in there. So deep wells are for deeper, and these can be 6-point or 12.2. And then we have these ratchets,
Oh,
and they're different, right? Oh, let me get one more.
looks like quarter-inch drive, right?
That's not quarter-inch drive. This is a quarter-inch drive. You know how you can tell it's quarter-inch drive? That's a measurement. So if you put it on here, that should be 1/4 inch, and it's just about a 1/4 inch, right? So it's a 1/4 inch drive because this is 1/4 of an inch.
And this is a 3/8 drive right
And that's
here?
3/8. So that is 3/8 of an inch drive. And then this one is 1/2 inch.
Half-inch drive.
And then if you go out in the barn when you're having a really bad day and got to get in the bad day box, what do we got in there?
Inch drive.
We have 3/4 inch, an inch drive in there, right?
Yeah.
That's for when you have a really bad day. These aren't too bad. You get the bad day box out. There's some big tools in there, right?
This sounds a lot clickier than the other ones.
Well, it's because they come in different teeth. See, click that one. You know, hold over here if you want people to see it though. And click, 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 click. That is a coarser tooth than this one. So for the same amount of turn, you get more clicks. And that means it can turn a smaller amount, see? This one, if you want to make another turn, you got to turn it quite a bit, right? To get it to click again. But this one, you have to turn a lot less to get it to click again. And that means you can turn tighter spots, right? Also means these gears are a little smaller than those gears and probably weaker. Like we might break this one before we break that one if we're really hulking on it, right? So they're different gear teeth.
How come this drive moves a little bit when I change direction?
Because there's a little pawl in there. We can take one apart later. Remember we took one apart already?
Yeah.
We got a rebuild kit coming. So now you know that that is 1/2 inch drive. And it only fits 1/2 inch drive sockets. This is 3/8 drive, right? These both are 3/8 drive, and this is 1/4 inch drive. So now you know how to work tools.
I think I might have. Might be the same drive I have my ratchet.
Well, we put a 3/8 in there too, didn't we?
Yeah.
Yeah, we got both now, right?
This. We got a 3/8. We got this one, which is the tiniest I own.
What else do we talk about these racks? Remember we talked about why everything's on these racks?
Why everything is on those racks is so. Probably because they're sorted, so we can sort them.
That helps keep them sorted, right?
And it helps keep from standard and metric apart.
It does. So now I know these are standard and these are metric, right? What else does it do?
Keeps them in order.
Keeps them in order. And I told you one other really important thing to put them on racks. Instead of throwing them in the bottom of your toolbox.
So they don't get dented.
So they don't get lost. Right now, if I pick this up out of my bottom of my toolbox and went, hey, what the? I'm missing one. And I can tell I'm missing one right off, right?
Yeah.
So if you put them in a rack and you put them away, you can instantly tell that you're missing tools, and you can take a minute and go find where your tool is, right? Because these aren't cheap.
What makes the ball go in when you push this
Well, they
clicker?
can't see that. You're going to have to hold it above the... Let's use a bigger one so they can see. That ball there, that goes in, and that's what holds the socket on, right? So if we put this on there, we can make this socket go on real easy, and then it holds it on there pretty good. There's a little groove in there, which is too dirty to see. But if you look in there, there's a little, kind of a little dent, groove inside of there that ball clicks into and makes it hold on. But that spring pushes a wedge. See right now that ball's all the way down, right? And when you release it, the wedge comes up, and then it's really hard because now that ball bearing is pushing against a wedge. But when you push it back down, it has room to move. And that makes it so you can get your socket on easy and off. But there's a problem. In order to make this work, you had to drill a hole, not us, but someone else had to drill a hole through here to make room for that wedge. What happens when we drill a hole through that 1/2 inch chunk of metal?
It weakens it.
Yeah, now when we crank on this, we can break it off easier, right? I haven't really broken one that was off though. Right,
Weakens
we
the
want the
head.
ones without it, and I think all of mine have, no, this one doesn't have it. See, this has got a spring detent, it's different.
Is that a snap-on?
I think this is actually a S&K. So this one doesn't have a push button, but it's still got the ball. But what happens is, if you find something hard, we can push with there, dirty old screwdriver, we can use that. There's a spring back here, and if we push, we can push real hard, and that will go in. But it's under spring pressure, right?
I think this might be the drive I have in my toolbox. I don't think I have this tiny of drive.
You got 1/4 inch and 3/8.
Oh, that's because I got a swivel ratchet.
Yep, we gave you the swivel racket, kind of like this one. Not quite, but it swivels down here, right?
That swivel ratchet might have been useful for trying to check the bearings in that skateboard.
Yeah.
Because
This one's awful loose.
when I was trying to get the wheels, I kept on hitting the footboard.
I don't think that's good. Look at that. I don't think that's very good. We might have to.
Hey, you did say we were going to take a ratchet apart.
Well, we ordered a rebuild kit for that one. For this 3/8, we ordered a rebuild kit for that. So maybe we'll rebuild that. But this one, I don't know. It's awful sloppy.
What was wrong with this one?
That one's a good one. But we have 2 in the barn that are broken, right? We have rebuild kits for them, right? Well, what else you got questions about? You understand everything?
Yeah.
Makes sense? We think we explained it good? Do you understand these fractions?
Yeah.
Let me move all this stuff out of the road so we can get our picture back. Ugh! Look how messy it looks. Made sense when I was drawing it. Does it make sense now? Like we started here. If we just started here making a video and we were like, there you go. What would it look like?
And if you make me divide those, I'm going to faint.
Those are easy though. Well, check this out. It's easier than you think, man.
You got to divide them 1,000 times.
No, check this out, all right? So if we're going to divide this into 1,000, that's 1, right? Let's scooch down so we can see what we're doing. This is 1,000. What's half of 1,000?
100?
No, that's a tenth.
500.
500, right? Right there in the middle, 500 thousandths. All right, what's half of, we can take these zeros away, right? Let's take one of these away to make it easier math, right? What's half of 50? Think about your dollar.
My $20 bill.
You got dollar, $1. How do you divide it with quarters?
4 quarters equals $1.
And how much is a quarter worth?
25 cents.
25 cents. So this one, 250 thousandths. And if we go over to 3/4, because you got 3/4 makes how many cents?
25 plus 25. 50. 75. 750.
That's all we're doing, the same thing, right? We started with 1,000 and we're just dividing it into chunks. But we're not going to, a lot of times we don't need 1,000. We need a smaller amount, right? So we can come up here and we can divide these further. I don't know them all in my head by memory. I cheat and use a ruler. But I know that 3/8 is 0.375. And I know that 1/4 inch, we did 1/4 inch, 1/8 inch, 0.125. And all we did was divide 250 in half. And we get 125, right? And if we divide the 16th, 0.06, I think there's some change.
Your 6/16 looks like the word glue, but with a crappy U.
Making fun of my handwriting now?
Yeah.
Yeah. Do you understand how the thousandths work, though? It's the same thing, right? We've taken this one thing and we divided it into sections, just like we do with the fractions, only now we're calling them decimals.
I have a Math Shark. You might be able to use it for a calculator.
You can translate in your calculator. You can convert fractions to decimals because, look, they're really the same thing, right?
And a calculator can show you which way.
You know where the calculator is? Is there one in there? Other drawer. I don't know if there's one in there. I think it's over on the mill table. Oh, there it is, the green one.
Let me get the cover off once I pull it
It's a
up.
little worse for the wear, right? Look at this thing. I've dropped it a couple times. This isn't even a very complicated calculator, but you can convert. And if you look at these, I don't know where it is on this one right there. See that A, B to C? That converts fractions to decimals. So if we go on, clear Clear, clear, clear. All right. So if we go on and we want to put 0.500 in there, I don't remember I don't remember how to do it. Yeah, see, I'm not sure if I'm smart enough to use this. I think we gotta go to second function.
Maybe we should take it to Mom, the computer genius.
There you go. So that divided, that didn't really help us though, but it's a 1/2 inch, right? So you can convert, you can do fractions on this. I'd have to look up how to do it. I don't convert. I just like decimals. Decimals are easier because I measure in decimals a lot, right? So I measure in thousandths. So I like things to be in decimals more than fractions. Fractions are hard. They're not that hard, right? You understand this, right? They're not complicated. It's just, they're not as intuitive. Metric, however, these guys, they got it going on. Because look, right here, we have a centimeter right there, right? So they made 10, and we can do 10s easy. 12s are hard. Fractions are kind of hard. We can do 10 way easier.
I think I just transferred 800 into decimals.
Well, we can look. I'll have to look it up. I think it's this button. I was using the wrong button. See that fraction decimal button right there? Mm-hmm. Let's see if that's it. We want to go. Where'd my button go? Oh, I can't see. There it is. We want to go to second fraction decimal equals. Look at that. 1/2, same as 0.50. So we can do that. Let's check this out. Let's see if we can figure out. We want to know what the decimal is for 13/16. I don't know that one offhand. Do you know that one?
No.
13/16. Let's see what the decimal is. We hit this, and then we hit the fraction decimal button, and it says, oh, that didn't help us, did it? Well, maybe it doesn't go backwards. I've got one of these has to work it, but I'm not sure which way. Oops. Ah, that didn't help. All right, let's try again. 13/16. And we want to maybe have to enter 0.8125, and then we can convert it back to decimal. 0.8. So that says that this, we did 13/16, right? I forgot what number I typed in. I think that says 0.8125. We can check that on a handy cheat sheet, which they can't see in the camera, but if we look on the wall over there, see that tap chart right there?
Yeah.
If I scroll down and look at 13/16, I can't read it. My eyes aren't good enough. Where is 13/16? 13/16. It says it's 0.8125. Ta-da! 0.8125. Almost like we knew what we were doing, right?
No.
All right, you want to check some of these other ones?
No.
What you trying to do?
0.800.
800.
Second, I have to enter.
And that gives you 0.8, and then second, and then hit this one. See, I don't know what you're trying to accomplish. I don't think that was it. You wanted that one. What are you trying to figure out?
I'm trying to see what the decimal of point.
Well, it goes the other way. So when we divide these, let's say, let's do 11/16, right? 11 divided by 16th should give us a decimal. Here, 0.6875, right? And then if we want to convert that back, so we can take that and then take that back to fractions, and it should be 11/16 again, because they're the same number. It's two ways to write the exact same number, right? One is decimal and one is fraction. I like decimals better. Easier to do math. Fractions, because you'll learn when you get in school to add and subtract fractions, you got to change common denominator. You got to have, it's a mess. So we're not going to do that yet. What else? Poor broken calculator. Let's put our tools back away. Remember, we got to have them all together so we won't lose anything, right?
What's that line doing on that camera?
That's a safety line, because I made this rig to hold our camera. But if that rig fails, what happens to the camera?
The camera falls.
Mom would be grumpy, wouldn't she? So I put a piece of string on it, and now if the camera rig fails, it'll just swing. And it won't break on the bench. Because the bench is pretty hard, right? We don't want to do that.
If it starts looking like it's going to come off the bike, I'll be like, nab.
I don't think you can catch it that fast, because it's pretty hokey over here, right? Like, I did a pretty hokey rig here. Does this all make sense to you?
Yeah.
All right, I'm going to ask you questions later. It's going to be a test.
I'm going to faint, maybe. I might faint.
All right. You want to stop the video and talk about something else later?
Yeah.
Okay.